20 seconds left in the match. Litter, marked with the opposing alliance color and not in scoring position on the field at the end of a match, is considered unprocessed litter, and each piece will add 4 points to the score of the opposing alliance. Alliances may work together to earn a 20-point cooperation bonus by placing 4 yellow totes on the step. Stacking these 4 totes earns an additional 20-point bonus for each alliance. To rank well during qualification matches and advance through the playoff matches to the finals, teams will want to maximize their score for each match. Simply outscoring the opposing alliance on individual matches does not guarantee improved rank. Information displayed after each match will show how the team's performance affected their average score and current rank for the tournament. Of course, robots will need to be built robustly to avoid damage from falling game pieces. Have fun with Recycle Rush and good luck!
Okay, so so just from that, what's up?
Did they have Dozer in the video?
No, so this was the first year of not having Dave Lavery do the game animations anymore. They also had incredibly small amount of time to put all this together. Like, I don't remember exactly when they filmed this, but it was like sometime late December. They like filmed the intros and stuff. Like, some of it had to be live because they couldn't do the animations like they normally do for a lot of it. Right? The voiceover is very meh. Yeah, like it was a super rushed reveal. The game itself was even pretty rushed. So like the pool noodles didn't get added to the game till sometime in, I think, late November or December. Like it was super late. There's like adding elements to the game. They added the whole like scoring step, like these white platforms. Those weren't in the game at some point. Yeah, it was a lot that they changed kind of right at the end to try to make this game salvageable.
The Recycle Rush.
Yeah, it was an interesting year in FRC. So parts of, before we get to our bad robot, yeah, so it was an interesting game in that there was no defense, right? So that you couldn't cross the step at all. So you were only playing on half the field. You didn't get any win-loss points. Like your win-loss record did not matter until the finals. During all of qualifications and quarterfinals and semifinals, only how many points you scored mattered. So instead of it being like a normal, you have to win, it was like, no, you just want to score all the points you can, which was also awkward for a variety of reasons. And it was probably one of the hardest games to actually score a meaningful amount of points, because to get a lot of points, you had to get a big stack of totes with a recycling container on top of it to do it well. Okay, so most of what we're going to do today is look at design. A lot of what we're going to do today is look at bad design of our both of our robots, honestly. So this is the first robot we built, design number 1 of X-Ray 2015. There are some basically all very bad design intent. The original idea was it's supposed to partially be inspired by 148-2011, but we did not do that well. We did not understand a lot of things that we were doing. There was also a bunch of bad strategy design and like how we'd actually play the game, and a bunch of bad mechanical design and how we'd actually build it. So let's look at how that is bad. I have the CAD pulled up. I'm going to screen share SolidWorks, hopefully. Get to where I can just not have it under there. Okay. Okay, so this is the full CAD for our 2015 our 2015 initial robot. As you can tell, there's just like not a lot here, right? Compared to a lot of our other robots, there's just literally it's just missing a lot of stuff. There's like a belly pan that's not CAD'd or shown right now. It might be hidden. Where the belly pan is. Belly pan and parts. Can I show this?
It's at the top, change transparency, next to edit assembly.
But no, it's not transparency. It needs hide show, and hide show is not there. That is confusing. It's not set to resolve, maybe? I think it's probably set to resolve, hopefully. It also may not be able to find it. It's not like we keep track of the 2015 CAD very well, so like it may have gotten messed up in GrabCAD somehow and non-existent. It's trying. Okay, so yeah, so parts that aren't resolved, they don't like solve all their mates, so it doesn't always like float in space, and if they're hidden, it doesn't let you see them sometimes. And that happens a lot when you get a bigger assembly. So now it'll come down here, like in the very bottom right corner, it says editing in large assembly mode. That takes out some of the details and some of the features it would run normally, and it lets it act a little bit nicer than if you don't run it in large assembly mode. So yeah, so it had a cleanish belly pan. It was the only time we've ever had a West Coast drive robot, which means the wheels are cantilevered away from the extrusion here. Most of our robots are sheet metal, where the wheel are between two pieces of sheet metal, and normally dead axle, which we'll talk about later. But this is kind of the standard FRC robot for a lot of teams who aren't using the Kitbot. A lot of teams build something like this. So the drivetrain of this robot was pretty reasonable. There's nothing too fancy about it. Here's just the 2x1 aluminum extrusion. These blocks right here are called Versa blocks. Let me hide some stuff to make that easier. Actually, I might isolate the Versa block. So this, maybe. All right, it was very black and very hard to see. Okay, taking off the display settings so you can actually see the block. So yeah, so this is what's called a Versa block. They came out in either 2014 or 15. I'm not sure which one. It might have been 2015 actually. And it basically allowed you to put a bearing block onto any 2x1 rail really easily. So these big holes are where the bearings go. They have the Versa key pattern here. So these like mate with different hubs. So you can transfer torque to like an arm or something from a sprocket nice and easily with the Versa hub, with a Versa block. And they just clamp around a tube so they can actually slide a little bit too. So you can tension the chain if you have them sliding across the tube. And SolidWorks decides to load back everything. There it goes. Okay. And then the gearbox for that robot, we didn't make our own or anything. We just bought. So these two plates, there are gears that go in here that aren't showing up in SolidWorks right now. I don't know if they got hidden at some point or if they're just not resolved. Yeah, so all of these ones that are kind of empty, they're just not shown. So a lot of that stuff's all hidden. So this is what the full gearbox looks like. We can do show components and see it all. Okay, so now you have the gears in there. So this is a pretty standard double reduction gearbox. If I don't go anywhere. The two sim motors drive this first gear, and then it's on the same shaft as the second gear, the second small gear, and it drives this other larger gear, and we make the wheel spin quite a lot slower than the motors. It's catted with 4 sims, but we actually only ended up using 1 on each side. So you only need 1 motor on each side in 2015 because you were never pushing anyone out of the way. So you didn't need the extra weight. You didn't really need the acceleration. It was totally fine to just run 1 sim on each side of your drivetrain and be done with it. And we did that for, I'm pretty sure, for the whole season. It's regular extrusion construction with just gussets. So we had gussets that we had Solarcraft make for us. We actually did all the tubes on our router. We figured out how to do all the holes and stuff on the router that year. It took some doing to figure out how to do it all, but they did eventually work out pretty okay. They didn't have to be super perfectly spaced or anything since we were using those Versa blocks. That was constraining the shaft and the bearings and everything, so we didn't have to worry too much about where these holes were or how perfect they were. And then to power the back wheels, which were Omni wheels, we just had a chain run along the outside of the tube going all the way back to the back set of wheels. And then this little thing is the cam, which basically if you tighten it, you can like change how hard it pushes on this block, and it'll push the chain and make it tighter, so the chain can't fall off by just like spinning this bolt around or spinning this cam around and pushing this out to the side. So they're useful to be able to design things where you want to be able to adjust tension. If you have something that can slide, like this clamping bearing block, you can slide it that way and keep your chain tension so it never falls off. Throughout this, please interrupt and ask questions if you have anything, or if I'm going too fast or if something I said doesn't make sense. Because I'm having to go back and remember a lot of the stuff we did in 15 too. Okay, so past the drivetrain and belly pan is where this robot starts getting very, very bad. We didn't know just how bad until pretty late in the season, but it was not good. So we can look at a few different things here. So like, this is a single hex shaft going through 2 bearings, a hub, another bearing in this arm, 2 bearings in these 2 plates for this gearbox here that has gears, but they're hidden. And then another bearing, another hub, and 2 more bearings. So installing that was not fun. In any of your designs, we should know that like trying to, right, this hex shaft starts relatively straight, like that's its goal, right? From the factory, we want it to be pretty much in a line. So the only way that this works is if every one of these other parts that it's going through are also perfectly in a line. That is very hard to do. Turns out it doesn't work very well. So that's problem 1 of many. Problem 1, off the bat, anytime you see something like that where you have a hex shaft going through a bunch of stuff, just know it's going to be a pain. Like trying to install it, you're probably like sliding it in from one side. So we'd like try to stick the hex shaft in through here, get it through this bearing, get it through this one, put this arm into place, slot it through. This wasn't even Thunder Hex, by the way, so it has to be like rotationally correct to the hex points on each of these hubs and bearings. So it took a good 10, 15 minutes just to slide this through, if that, and you probably needed a mallet. It was a lot. Here's some, what is this? This is some silliness to try to put an encoder where we were gonna like 3D print gear here. So it had to also, the shaft also had to go through this gear that you had to add on in the middle. If this was actually gonna happen, I don't think it's ever got installed. It might have. And then we're gonna use this other motor spot for the encoder or potentiometer, like a sensor to be able to tell rotation. I don't think that ever worked. Pretty sure it didn't. There's definitely a way to get something like that to work. This just was never designed enough to do that. Okay, before we go up the arm, let's look at the gearbox. So just bad all around. So this is a COTS VexPro like single speed gearbox. I think this one is 12. This is 12 to 84, which is what's 84 divided by 12?
7.
7, yeah. So this is 1 to 7. So for every 1 time, or sorry, for every 7 times this small gear spins, this hex shaft will spin once, right? So we're getting 7 times the torque onto this hex shaft and 1/7 the speed. Because that's what gearing does, right? We're always trying to, most of the time, we're reducing speed to get more torque. So feeding into that, we couldn't just put 2 sims directly because we'd still be going way too fast for this arm, right? Because if we come back a little bit, we'll look at how the arm is built in a little bit. But at the beginning, the arm basically only had to go from here up to somewhere like that, right? So those are the arm positions in this sketch. So you have that dot and that dot. That's not an actual lot of movement, right? That's, what, is that not even 90 degrees somewhere? Yeah, it's not even 90 degrees. Like that line to that line isn't quite 90. It's somewhere close. Let's call it 90 degrees. So it's moving 90 degrees. So it had a whole quarter of a turn it needed to be able to do, right? So a lot of that, it's just going to be spinning way too fast if it only needs to move a 90 degrees at all. So to slow it down even more, we thought it would be a good idea to put the 2 sims into versaplanetaries before we put them into the gearbox. I'd have to go back and look at a lot of sheets to figure out what stages these were, but I'm almost certain they were like somewhere around 50, like a 10 and a 5 maybe. It's my guess if I had to remember what we did. So there's like a 1 to 50 reduction in these planetaries, and then a 1 to 7. So we have, no, I think it was more than 50, because that only puts us at 50 times 7, which would be 350. And I think we were more than that. But even if that's all it was, that's still a silly thing to do. I don't know how we never did math. I'm not sure what we were doing, but it was just altogether not good. So we built it, and it largely kind of worked. Like the arm moved up and down. It did what it was supposed to. But eventually, I want to say we were practicing at Pearland Shop. It's the first time we ever went to Pearland Shop. There was a tote. We tried to pick up a tote from the landfill because they had it all fully set up and everything. And part of the design constraint problem is we tried to pick it up, but any arm doesn't swing. It doesn't go straight up and down, right? When it goes up, it goes out as well. That makes sense why that's going to happen, right? Like it starts down here, it ends up over there. So because we tried to pick up this tote from the landfill and there's another tote behind it and the step, there was no room for the tote to extend forward any without running into a relatively solid object that is the step that's Velcroed down to the carpet. So it resisted being pushed forward, which makes sense. So then if the arm can't go forward, it can't go up. If the arm can't go up, this shaft can't rotate. And then that leads to a problem, right? If the motors are trying to rotate the shaft and the shaft can't rotate, you end up in a very bad place. So that's what we call stalling, right? The motors are trying to turn and we're not allowing it to. But because we had so much reduction, right? We have so much reduction that we have so much torque or rotational force. The motors are trying really, really hard to turn this shaft. So hard, in fact, that they twist this shaft. They twist this hex to where no longer the flat's going flat. It's twisted like a Twizzler, basically. It was just a full-on helix. It did multiple rotations. And at one point snapped. So it twisted a lot and it snapped somewhere near the gearbox, I think. It just whoosh, hex shaft no longer together, just full shear, torsional shear, gone.
Why wouldn't it push it away? Why wouldn't the robot itself move backwards?
The driver was driving forward, I'm pretty sure. But yes, that is an option, but it only kind of works. There's some locking of how the arm worked too that may not have let that work as well. But yes, that is an option. It could have pushed it backwards, but somehow we locked it, or the driver was driving forward. Something was going on to where it could not change its distance between the drivetrain and the tote. So that was bad. It sheared, and then we were sad. And then we were like, oh, it's sheared. It just needs to be stronger, because that's an answer to a problem. It is an answer. It is a bad answer. That should not be. That's very. See, we think we'd learn, but then we had 2019's Climber, and we did not learn, because we did the exact same thing. But
looks very similar to this, in fact.
That's not that different. It's not that different. So continuing on and how we don't learn from our own mistakes. And we absolutely should, which is why we're going to teach all of our mistakes over many years, so that hopefully you all can remind me to not do that again. So we replaced the aluminum Vex Pro hex shaft, which is like 70-75 aluminum, which is pretty strong, with a steel hex shaft. And that actually does mostly solve the problem. We're able to, we don't do it again. I don't know if we probably changed some of the driver stuff. We tested in our lab. We lift up totes, and it kind of works. I think we do start letting the robot get pushed backwards. I'm not really sure, but it hasn't broken. And then, so I take that back. We twisted the aluminum hex shaft before we went to Pearland. I said we did it when we were there, and that's not true, because I know what we broke when we were there. This is different. So steel hex shaft is already in place when we go to Pearland, which is I think we're leaving for Arkansas on Wednesday of this week, and we go to Pearland on Saturday, right? So that's 4 days before the regional. We go to Pearland with our practice bot that has a steel hex shaft on it, and we try to figure out what's going on, and we see if it can work. When we're at Pearland, we have the steel hex shaft. We do the thing up against the step, and instead of this shaft twisting, the output shaft of the Versaplanetary shears off. Both of them on both motors. For a while, I don't know if we finally threw them away, but for a while they were just hanging out in the shop. They were just the output shaft of the Versaplanetary with the gear on it. It's kind of bent and just sheared, and they're so gross. They're just in the VP box for a while. I don't know if they still are. But yeah, they're just completely gone. That was a very sad day. It happened really quickly. We got to Pearland, and I'm pretty sure we snapped those in the first 10 to 15 minutes of us being there. So that was bad. We then proceeded to pack up because we couldn't do anything else because the arm didn't do anything, right? And we went and got snow cones, and all very sadly ate our snow cones.
Snow cones.
Is 100% how that trip went. While at the snow cone place, we had already realized, so this was in Arkansas, I think it was week 4. So we'd already seen 3 weeks of play. So we already knew we weren't on the right track. We were just trying to salvage Arkansas. While eating snow cones, we realized that wasn't going to happen. We weren't salvaging Arkansas with this robot at all, right? There was some talk of trying to play with this one while at Arkansas, building up a thing that we'd be able to play with at Bayou, our second event. And that which wasn't going to happen. So we had to realize we had to very quickly accelerate our rebuild plans to be able to rebuild at Arkansas. So we had already done some amount of catting on the next robot, but it was a lot of rough. It was still rough. We'll get to the rebuild in a second. I want to talk about the rest of this robot because that was the killer failure, the absolute, oh no, don't ever do this, worst thing. It's not like the rest of it was good. If the arm worked, it's not like it would have been a good robot. It would have just been a bad robot with a working arm. So just a whole lot of not great things happening up here. So these were
it's kind of top heavy when you pick stuff up with the arm.
Oh, it would have been very top heavy. That's not even the problem. So there were other issues though. So this is the pivot points for the two arms, right? and they are just 1/2-inch round shaft with like bushings. Not terrible, but if you load this at all, these will bend, right? 'Cause a huge amount of the resistance to bending of any like shaft is its outer diameter. So that is why we try to put larger tube where we can. So if we were going to try to like rebuild this to be a good robot, which again, this strategically, this robot was bad. There were like, you shouldn't build an arm in this game, just period. But if we're going to try to build a working arm, these tubes would have definitely gotten larger. There's no reason to have like the bearing blocks here. You figure out how to put the bushings in the tube themselves somehow. The other way we tried to reduce load on the arm so it wasn't having to lift all of it itself and like trying to twist that hex shaft was we had these very large gas springs attached to the tube and to here. So they were also lifting the arm. So instead of just like using surgical tubing or anything, we tried to use gas springs that are like out of your, like the back tailgate of an SUV or something. Gas springs aren't inherently bad. They're just a little bit trickier to design. You kind of have to design them like pneumatic cylinders. So you have to get the two different pivot points exactly right and kind of make sure they're working through the whole arc that you want it to move. Also, this is catted upside down. Ideally, any gas spring is mounted the other way so that the rod end is coming out the bottom or whatever gravity's acting on it more, because there's like oil inside of it and it oils better if it's all upside down. So also don't CAD them like this because that's not how they mount. Like if you look at the back of your SUV or something, they're always the other way because they lubricate themselves. Okay, so yeah, so that's part of the arm is very, very meh. You can also counteract that went away. You can also counterbalance a 4-bar by having surgical tubing run from this top pivot to this bottom pivot. The reason for that, I don't think this animates. This does not. Oh, it does animate. Oh, wow. Hey, we made all the pivots properly. I didn't realize this actually worked. Okay, so down here, I don't think it actually, I'm not going to try to get it all the way down. But either way, down here, if you kind of think about the way the triangles work, because this side stays the same always, and this side stays the same, but then this angle moves, right? So these do change their relationship to each other. And this point gets closer to this point, the higher the arm goes. We can prove that with the measure tool. So down here, it says it's some number. What is happening? Black distance. So yeah, it's 48 inches there. If SolidWorks wants to cooperate. It does not want to cooperate. It's mad. Okay. If SolidWorks cooperates and we bring it up, we can see that if I actually select the right entities, hopefully. This one to this one is only 40 inches. Does that make sense? So because those two things are getting closer together as you go up, if you put a bunch of elastic around them, it'll want to help bring it up because that's the way that it can be closer together, and the elastic always wants to be closer together. So that'll help balance it a little bit and spring it up a little bit more. Okay. This thing is just not good. This whole front thing was very, very awkward. There's a lot going on. Here are like custom little like linear slide things with pneumatic cylinders that were designed to be able to tip this front forward and backwards a little bit so that we could hold the tote better. But it got really awkward when we tried to do it, and it did not work very well. This was like a 3D printed thing that went inside this tube. It was just a piece of Thunder Hex sliding in and out of there. We really wanted to use the 3D printer a lot this year. This is the first time we had one. It's not the best option. You shouldn't just design to new tools that you have. You should actually like make sure that's the design is reasonable first. And then looking at this thing. Oh, I forgot it even tried to do a thing. That is really silly. So this little like thing that looks like a mustache interfaced with the side of the tote. So it would kind of like lock in under this handle.
Yeah.
Does that make some sense? But you still had to be pretty accurate. So like the idea was like in our head was like these wheels would just like center it. They don't. Like, they don't.
So is your plan to just pick it up from the side and not from like the narrow side, not the broad side?
It's because they come out of the chute door from the narrow side, and like most of the ones were on the narrow side in the landfill too. But hold on, it gets worse. So the little mustache piece also interfaces with the wide side. It's not in CAD, but there is a little bit of a lip that you can grab onto on the wide side as well. They didn't CAD that part of the tote, but in real life it exists. And you're like, but wait, how would it reach there? These wheels are in the way. That's a reasonable thing to think, except we forgot about these pneumatic cylinders back here.
Oh my God.
Which were like, there were like two nuts attached to like this plate. And there were like another one of these very jank Thunder Hex linear slide idea things that we were attempting. Some of these 3D printed parts I think are still hanging out in the lab. And so just, this was supposed to slide. I want to be very clear. It doesn't slide. So we were smart enough to have two of the slides, so it does try to balance it. So there's like two slides on this panel that are screwed into this. There's this little back connector thing, which we had a bunch of these hanging out in the lab for a long time. It's such a weird part. It looks like a batarang. And there's one on each side, but it's not pushing. Each cylinder is still not mounted in the middle, so it's not pushing even across these 2 points. So it still wants to bind, like the whole thing still wants to like twist. So that just wasn't good. Anyone know what this weird crown-looking thing is? Any clues? Any ideas?
A tracking system without a tracking system.
No ideas. By the way, so fun story. This piece and this piece, why I'm not sure, are made out of 1/8" steel. Legitimately no clue why that is true. But that would be why there's so many holes in it, because they are made out of 1/8" steel, yet we wanted it to be lighter.
You are still wondering about that?
Thank you, Michael, for that one. So that's fun. Okay, so yeah, so we didn't actually talk about what the function is. So what is?
Is it for the recycling?
Is it an
It is in fact for the recycling bin. So this would go under the recycling bin, which is kind of curved, right? It was designed to fit around the curvature of the recycle bin. By designed, I mean someone bent in an angle, and we made Solarcraft bend this thing for us. Yeah, it wasn't great. But that was for the recycle bin. So the recycle bin go higher, right? Like if you're grabbing it all the way up there, at the end of it, it'll be taller than if you're grabbing it low, which makes some sense. But yeah, so that was most of that robot. We had a pretty good control panel on it. Similar, like we took some of the things from 2014 and made it a little bit better. This is the radio from back then. There was like a pressure gauges here and the regulators. They were all much larger than they all are now. They're like huge back then. There's a voltage cutout. That wasn't the power switch. I don't know what that's for. Oh, that's the blow off. That's the pneumatic release valve, I think.
Are they similar to the ones from the H-Drive robot from 148?
I'm not sure. They're the same ones on like the old 2014 robot. Oh, there is a part missing from CAD that I want to be very clear was a terrible idea, and I don't know how we ran with it as long as we tried. Let me see if it actually exists. Because before we stop this robot, it's important to understand just how bad this robot was. We have not talked about probably its worst idea, which is saying something because most of it is pretty bad ideas. Where is it? Did we delete it? Was it that bad? Is it just gone? Collapse items. It should be in drivetrain. No. I think we might have just deleted it. Huh. Okay, I will describe it, and I think there's a photo of it. It's not anywhere. No, it is nowhere. Okay. So you'd be like, wait, why is there space up here that doesn't have belly pane? Good question. This was for a drop-down omni wheel that was perpendicular to the drivetrain, like an H-drive wheel. So it would lift the two traction wheels off the ground. But now you're left with this one omni wheel on the ground, perpendicular to these two omni wheels way back here. And somehow we thought we were going to be able to make that drive sideways, which I'm pretty sure there's video of it somewhere where it kind of sort of does it, but the programming is so awkward because you're having to, it would make sense if the wheel is here and it's pushing down and it's trying to rotate the robot, right? It's just going to drive the robot in an arc, right? It's going to these two are on the ground and it's just going to turn the robot like this. So to avoid that, you have to have these two robots trying to counteract the rotation of the robot to try to fight it going sideways. So the back wheels are just fighting rotation to each other, trying to
weird
spin
mechanism.
the robot. And it was somehow that we thought that would work. I have no idea. 2015 Spectrum and 2020 Spectrum are very different entities. We are, as a whole lot smarter than we were back then. I think let me check if it's in the photo. I'll screen share it. Oh yeah, it is in the photo. I'm gonna stop the screen share and do the presentation again, so that we can see it because it's oh man. Okay, so there it is. So there's a pneumatic cylinder, giant pneumatic cylinder. It's like a 2-inch bore pneumatic cylinder with a rod across it that would push down an omni wheel into there. Yeah, if somebody wants to dig through the Smug Mug and find the video, we can look at it. But it is rough. Okay, it's already 7:15. So I'm gonna. What?
What even drivetrain would that be called?
Good question. It's a very bad H-drive. Why we didn't just build a normal H-drive, I have no idea. We could have easily done that. It would have been a reasonable. All drivetrains that year are basically fine. Mechanism was fine. The 1114 Kiwi drive was fine. Tons of drivetrains were fine. That one was not fine. Okay, so left off. We're eating snow cones and we're all sad. So the snow cone day was the death of Robot 1, to be reborn at Arkansas. In some semblance of this thing you see before you. But to be clear, this robot was better. This robot was not good. It had a lot of holes. As the slide says, the intake was basically never actually designed. It did things. There were intakes. They were all built basically by hand, by us just throwing stuff together at events, largely. Because we never had a practice bot, right? Because we kind of we made plans, we did CAD, which I'll show the CAD in a second. we built this entire robot at Arkansas by completely destroying this robot, right? This was in the bag. This is what we bagged, basically, is this robot right here. So we bagged this, had to take it to Arkansas with 40 pounds of withholding, or 30 pounds of withholding. I don't remember how much it was that year. Some amount of withholding. The withholding basically entailed this rail made and the sliders that are on it that are going to help stack totes, and the opposite rail. And that was basically it. And then a ton of raw material. We basically had those two things, and I don't think much else. There might have been, I think we had to have this battery plate. Nope, I take it back. That was cut while we were there. Yeah, I don't think there was a whole lot of anything else. So yeah, so we had to completely tear down this robot. It was a massive problem. I'm not going to tell the 2015 Arkansas story right now, just because that is longer than the 45 minutes we have left in itself, and we won't talk about design anymore. But we did. We stripped the whole thing down. We built it back up. We got it good enough to be selected for the playoffs at all of our events. But again, not good. Better, definitely not good. Okay, to open that robot, I have to close the old one because they have the same name, and SOLIDWORKS doesn't like that. So I'm going to close the old one and then open the new one. Maybe. Any questions so far?
How old is Yan when this happens? Because I found a picture and he looks like a freshman.
This was Yan's sophomore year.
Okay.
Okay, I'm going to open Spectrum Rev 2 X-Ray. Maybe I'm going to open Spectrum Rev 2 X-Ray. What just happened, computer? Any other questions about the design? Largely, what you should take away from that are things to not ever, ever, ever do. Right? If anyone's like, "Yeah, we'll just do it like 2015," say no. No, we won't. We will do something else, and it will be better.
What are the benefits of West Coast Drive versus what we're doing now?
Most of it is manufacturing, right? So West Coast is a totally fine drivetrain. It is relatively easy to build, which is good. It's mad about cam data. That's not important. And it works very well if you can do tube, or even if you can't do tube, you can build, if you're using the Versa blocks like we did that year, you can build an entire drivetrain with just hand tools, basically, maybe a drill press, but you don't have to have any CNC equipment at all, which is really nice. You can CNC it and mill in all the stuff to the tube, which you can do on the router. Ideally, our new router will let us do tube a lot easier, so we may be able to do some of that. There are some little differences. So for us, the gearbox has to have more reduction in it for West Coast, because West Coast normally has a direct driven wheel, or at least normally doesn't have any sort of reduction after the gearbox, where ours normally have we have big sprockets on our wheels normally that give us this extra stage of reduction. West Coast drives almost never do that. So you have to have a higher reduction gearbox, which it's just a trade-off. It works either way. The sheet metal drivetrains work well enough for us. Our sponsors good enough at getting them back. We can design them. We get a little bit more flexibility in how we can design in some of our mounting points and things. You can change kind of where your belly pan is in relation to your wheels a little bit more than you can here, because largely the wheels in a West Coast drive are pretty much on the center line of that 2x1. So you're kind of you're designing off that structure every year, which you can definitely do. There are teams who build a West Coast drive basically every single season, right? Citrus, 254, dozens and dozens and dozens of other teams all do this every year exactly like that, and they are successful at it. So there's definitely a way to do it, and you can. If we think there's some reason to, we can. We like our sheet metal drivetrain. It seems to work, but there's no reason why we couldn't do something else. Okay, I have the other robot pulled up, and cool, it is screen shared. Okay, so this is all the CAD that ever got done for this robot. And much of this was never actually built. it's like the wheels are hidden, all sorts of stuff is changing. So yeah, you can kind of tell things that got moved around. So the gearboxes got moved to the back, right? So these rails stayed. This rail right here, the side rail on both front and back, or on both sides, stayed. And this back rail, oh, no, I take it back. We had to replace the back rail. So yeah, so the only thing that stayed from the two robots were the drive rails and the electrical panel itself, except as you can tell, it doesn't actually mount to this rail, right? Like it doesn't fit. So we had to make like these little like adapter plates that were really, really jank that just like went across here and allowed us to rivet to both things. Well, because the entire robot got wider. The rails were closer, were 2 inches closer together on Rev 1, and we had to open it 2 inches to be able to actually fit the tote inside the robot. So that's fun. So yeah, so this robot is inspired by Citrus from that year and 118 from that year. There were a bunch of others that were similar, but that was roughly the idea. We had to add in this tube. This tube would have a, we have a little bag motor and a versaplanetary here that drives a sprocket to this one, right? There's a chain, the single chain goes to here, and then another chain goes from this side of the sprocket up to this top sprocket. And this little carriage thing is attached to that chain. So when we drive it one way, this carriage moves up. When we drive it the other way, it pulls itself back down. The carriage itself is super simple. It was literally just 2 pieces of plywood that we routed out. A little bit of 1x1 that we just like stuck between it and clamped and drilled, and then riveted together. This little piece of L that we drilled holes for the chain that we can mount to it. And I don't think that they didn't end up in CAD, but there are bolts that have a bearing that ride this side of this rail, and there's another bearing on this side that rides here. So as it's being moved up and down, it is rolling on those 2 bearings, and the sides are just, there's plastic on the sides that it's sliding on the tube on. So overall, not great, but quick and easy and worked, because we basically had to, I think we had part of this catted before Rev 1 completely broke. But we basically had to go into the lab on Sunday and route all the parts and like have it built on Monday and Tuesday, because we were leaving for the event Wednesday morning, or whenever we left Wednesday. It might have been Wednesday. No, because load-in is Wednesday. Load-in's supposed to be Wednesday. Oh, no, yeah. We were supposed to leave early Wednesday and ended up having to not even be able to stay because the snowstorm and all sorts of other stuff that happened. That was 15 was a lot. But yeah, so we had to move. This was the belly pan. It got moved from the belly to the back. And then the control panel thing also had to have weird little brackets for it because it had to get moved up. These tubes all had to get replaced. I don't remember what this tube, oh no, these tubes did stay. The back rails did also stay. They just got moved. Did they get moved further back? No, they stayed where they were. They did stay where they were. Because we weirdly still have this shaft. Oh, yeah, I remember what we did now. So this shaft was the arm shaft, right? But or something similar, but this is now the joining shaft. So this sprocket, this double sprocket here actually drove to this sprocket, and it drove forward to this one. So we would do the same thing over here. It's just not all catted because we only catted one side, because we knew it was going to be mirrored. So then this sprocket, this shaft, they would all be tied together so that the 2 things couldn't like not be in the same spot and like tip the whole stack or anything. So they had to move in unison because they were actually chained together, and this shaft joined them together. So when either of these 2 motors spun, the whole thing had to spin. So it also meant if like one of the motors went down, we could just use one and it would still move up and down if we needed it to. Okay. Anyone have ideas how this thing works? This is just a bent piece of Lexan. And it's just going to pick this tote up, right? Right? So how does it pick up the next tote?
Does it just go down?
So it goes down, and then what happens, right? So if this tote goes up and it's holding this one, and then the next tote comes in, so like right now, I don't think I can actually move this. Oh, I can. So yeah, so if it's coming down, like say imagine there's a tote here, and it's coming down, what happens when it hits this next tote?
Yeah.
Bend out of the way.
It's gonna bend out of the way, yeah. So we were just using.
It just goes straight through the tote.
Yeah, that would be bad. So we were just using the bent Lexan as a living hinge. So it would bend out of the way. We'd push down pretty hard, get it to fold, snap under the next one, and then when we lifted this one, it would be lifting two totes, right? The tote that's on top of this one and this one. And then you would just do that over and over again. You'd go up, come back down, go up, come back down. And then when you were ready to drive with it or anything, we would kind of like lift it up a little bit to put some of the tote weight on our robot. And then we could drive it where we wanted, lower this a little bit and just back out, and the stack would stay where we left it. Make sense? What we never really figured out was, and it still is the hardest. So after you get your first tote in the right spot and you're against the little chute door where the totes come out into the field, the next ones are easier to like get into place. And so what we would do is we would figure out how to get like this first one in, and then we would pick up the second one and slide in the next one on top of this first one. Does that make sense? So like the third one would basically like stack in the middle. And then we would keep going with the, we would keep going like that if we were just stacking totes. Issues with this robot were, one, we had to figure out how to collect trash cans. So it kind of worked if we could get them in there sideways, and then we would lift it up and put the trash can on top. It was not great. So our trash canning was never very good with this robot. We were much better at just making a few stacks of totes at the chute door. And the intake ended up just being like random pieces of plastic with a motor and a Versaplanetary and a wheel just kind of sticking out here somewhere. They were also never very good. Let me switch back to the slide. I think you can see it in the photo. Where'd the slide go? So yeah, so in this photo over on the right, you can see, oh, you can't actually see it. You can see very bits of it. But yeah, this is kind of what the real thing looked like. We ended up having to do a lot of like weird tweaking and adjusting throughout the whole season. So there were like metal beams that were like, this was a 2x1 that's cut out. Like there's a whole U taken out of this 2x1 right here to be able to wrap around the rail so that it would stay stiffer, because we were like bending that whole, the whole rail. I think we eventually did add actual hinges and a metal plate here because the Lexan was bending too much under enough weight. Like once you tried to lift up like 4 or 5 totes, it would just fall. So we had to have like a metal edge there. There were like nylon rods that went up and down to kind of guard it because the totes would want to like shift on the inside and like fall in weird ways. So we were trying to avoid that. This upper thing, which the picture cuts off, are pneumatics and like a little pivoting rails that would like try to grab either the stack of totes or the trash can on top and hold it so it wouldn't fall when we went to drive around. Because that happened a lot. So annoyingly funny story. So this gearbox is just the COTS West Coast product gearbox. It's a very reasonable gearbox. Our Champs inspector made us tape over the gearbox because he thought it was a pinch point. I would like you to say that, one, that's like inside the robot. It's behind this run of chain, this run of chain, this run of chain, and this run of chain that he was not worried about at all. that are so much worse than this gearbox that you have to reach past all of those runs of chain to get to.
Like the gearbox.
So that was fun. So they taped that up to appease the inspector, even though it made no sense to do so. Oh, you didn't have bumpers that year, so you had to just have you just had to have your number like on a sheet of paper, basically. Like I'm pretty sure other teams had like real things. That's just a piece of paper with the number printed on it, just like stuck to the side of a robot. We printed so many team numbers because everybody forgot about this. So we would like have the printer, and somebody's job is like on practice day or whatever, just go around, find every team that didn't have a number, and then we would print them, except we would not give them a choice of font. So they all had Spectrum font numbers.
Yeah.
Also, to be clear, this isn't even the correct Spectrum logo number, right? Like this is the bad 7 and the bad 4. It's not good. Okay. Any questions about this robot before we look at an actual good robot from 2015 and look at 118's CAD, because it's actually good. This robot does not exist, by the way. It got taken apart quite quickly after our last offseason. We did play off seasons with this too. It got even weirder in the off season.
How did it get weirder than this?
There was one off season where I think the captain of the alliance was 2468. I want to say this was maybe Remix. We got drafted as the third bot because we were having some of the events we were actually doing pretty well because again, it was very easy to be. It was very, very hard to be very good in this game. So there weren't a lot of good robots this year at all. There were a few, but there were not many. So a lot of the off seasons were just not. There weren't a lot of people making big stacks or doing anything close to what you see if you watch like the champs playoffs or anything. But at Remix, I think we fell to the third robot, and we couldn't do much. I think their stacker might have broke at that point, and we also just weren't caring all that much. It was the last event. We were just like, no. We get drafted, and they're like, okay, all we need you to do is get one trash can off the step, and then like bring it to the floor so we can use it. We're like, how are we going to do that? They're like, oh no, don't worry. We have clamps and a broomstick. So there was some like weird clampy broomstick thing that was created that allowed us to like fish for the trash can. Like Ian would just like drive over and like try to like figure out how to hook this thing in there and like drive it back and then shake it off the stick. I think we did it at least 2 of the matches. We got pretty good at it. That was one of the ways it got weirder. I'm pretty sure there were other things we did in the off season that made it very odd. I think we like played with the intake a bunch.
It's just like shoot out and like sticking like the hole in the top and just like
Well, but it wasn't like it was just a rod with like a hook in it. So we would just like drive and like swing it up the top and then just like kind of shake it around until it would fall in and we'd pull it back and shake it around and get it out.
It's an art.
And it was like a broomstick and a couple clamps. I think there were multiple clamps. I think the clamp was also at the end, but it was also just clamped to our robot. Because there wasn't any. Oh yeah, so part of the rules there was only a transport configuration. When you actually started the match, you could be as big as you wanted, which is how 148 was like literally like half the field big. They had like strings and things tying them together. Okay, so yeah, so actually good robot and good design is 118's 2015 robot. It still had one of the 2015 things that got taken off, which not all their robots do, but that year definitely. All right. What is happening? It is playing in very bad quality. Okay, let's try that again.
Right, kick back, relax, and grab yourself a beverage. A hop if you want to just bounce to my leverage. The evidence, as they say, is in the pudding. So show me the money like my name is Cuban Gooding. It ain't fool's gold, it's gold, fool. Can't stop, won't stop, keeping it old school. So cool. Big Spoon is my nom's a plume. I keep it popping like a needle in a new balloon. And if you don't know by now, then you need more schooling. Let loose, kid, get stupid. Got more flavor than I know what to do. It's to get your hands up if you're part of the movement. And bump to the baseline. I made it right before your phone had FaceTime. Yes, sirree, you know my steez. I stay fresh to death like I'm drowning in Febreze. Up, up, and away we go. Up, up, and it's making me glow. Up, up, and away we go. Up, up, and liking it. Up, up, and away.
Thoughts?
Oh wait, so the trash can didn't have to be like upright on the stack?
It does not have to be upright. No, it did not.
Okay.
And the most people, yeah, that was actually one of those things that not a lot of people realized during build season. I don't think we did. I'm almost certain we didn't. And that ended up definitely being the way to play the game. Was you just always picked up a knocked over trash can, because writing trash cans got super awkward. There were some teams who could do it pretty well. 11-14s was pretty good because they needed an upright trash can, and they had a little kicker foot that would come out, and like as they intaked the wrong trash can, it would like tilt over it and swing up to the right position. So theirs was pretty good. I'm gonna pull up 118's CAD here in a second. If SolidWorks.
Their trash can claw is really cool.
Their trash can claw is the thing that went away very quickly. I don't think it ever was on for any of their events. Okay, SolidWorks share. Okay, so this is their CAD. It has some features that aren't real, like some things that I don't think ever got mounted. Like, I don't know if some of these wheels, like these little like wheelie bar wheels or this wheel on their intake, I don't think those actually ever existed. I'm gonna try to hide all the totes because there are multiple totes that need to go away. Not that. Great tote. Hide. Okay. So yeah, so largely, like I said, our design was based on, our second design was kind of based on theirs. So the principles are all kind of the same. They have a chain run that's modeled by that loop right there. So that's chain that loops up and around. Their like kind of carriage was definitely more complex than ours. This one has it hitting the intake, which it doesn't actually do. There's ways to, they can move their intake out and back in, which is a really kind of cool feature we can dig into at some point. I need to find other photos of that though, probably. Is the other carriage better? Nope, neither of these are all that great. But yeah, it's roughly the same concept, right? They kind of have this bigger flap. They have another flap here that helps grab the trash can. But it's doing roughly the same thing. So it's going to lower, get under a tote, pick it up, do it again to be able to stack all the totes. The CAD only has the intake on one side right now. I don't know if it's just hidden, but there was clearly an intake on both sides. It was very good at, because of how flexible their intake was and what they could do with it, it was very good at taking those totes out of the landfill, the ones that were already on the ground. It was one of the best robots at doing that and getting the full 3 stacks it needed to do from the landfill every match. And then it being able to do more sometimes. Some cool little parts. So this part is kind of cool. So this is the tube clamp for, they use tube as their rail. And I'm pretty sure this is printed. So it's printed as one piece. There's a gap in it. And then they just have a bolt that goes through there. There's probably a nut that's on the other side that's in a pocket somewhere or something along those lines. Let's actually see. Isolate. You can see if my guess is right. Ooh, nope, I guess it's a tapped hole or an insert. It might be a threaded insert, or it could be like a milled part. I don't know how they made it. I'd be surprised if it's a milled part, but it could be. But yeah, we could easily print this, put a threaded insert in here, and then that would let us bolt down and clamp a tube pretty easily, all in one part instead of having to do multiple. Let's see. Yeah, so their drivetrain wasn't much different from what a lot of people did. They had 4 sims in CAD. I don't know if they actually ran 4 sims all season. But they were an Omni wheels in the back and a traction wheel in the front. But they actually ran 5-inch wheels, I believe. It does say, yeah, 5-inch Coulson wheel. So they had 5-inch wheels, which meant they basically had to make their own Omni wheel, because no one sells a 5-inch Omni wheel. And then Does anyone know where the chain is on the robot to power the wheels?
Wait, are the front wheels on the inside?
The front wheels are on the inside. So they had to do that to be able to keep the width they needed for like their stacker to be as far forward as they wanted. Anyone know where the chain is for the drivetrain? Any ideas?
Is it in the inside of the frame or?
Yeah. So it's in tube. I doubt they catted it, but maybe. They did not. They catted the sprocket. Yeah. So now that that's transparent, you can see the sprockets. So this is called chain in tube. 118 started doing it pretty early. Anthony Lapp, who was a mentor for theirs and operated 221 Customs, which was, or 221 Systems, something like that, they developed some like custom sprockets to do it. So the right size, they're like 17 tooth sprockets to be able to fit inside the tube wall nicely. And it does save you some space, but it also is complicated because you can't just like rivet into the top of this tube section anymore because you'll hit the chain. It's also, you can imagine maintenance is kind of annoying because to build it up, you basically build a whole like long row of chain and kind of like feed it in using gravity to help get you there and like stick the shafts through. Like you have all the sprockets and chain together and you kind of like feed this whole thing down. So it's a little complicated. Some teams swear by it. Some teams really like it. I doubt we ever do any sort of chain in tube again. Our 18 robot was like a very, very poor version of chain inside extrusion, but also partially outside because it couldn't all fit inside the thing that we were doing with the way our wheels were and stuff. So yeah, altogether not great. But other teams use it. It works well enough. What else? This only has the old can grabbers. They iterated their can grabbers a lot during the season, like a ton, because all of 15 ended up coming down to which side had the most cans on their side. If you had 3 cans and could use them all and score them all, and your opponent only had 1 off the step, you were basically guaranteed a win. They could not score enough points if you had all your cans and you were using them. So the race, what was that?
Oh, you said something about like they scrapped the trash can arm. Like,
yeah, so this trash can arm, the crazy thing on the back, this one actually isn't the trash can arm even. The original trash can arm, this was something else. This was for, what was this for? This was for grabbing trash cans off the step after the beginning of the match, I think. I think that's what this one was for. So all this one did was it would let them kind of go, like kind of do what we were doing, what I was describing before, where they would kind of fish for the trash can. If they had, at the beginning of the match, they would grab 2 and bring them over. But in matches where their partner couldn't do the same, they would be able to clear the landfill, deploy this thing, grab a trash can, and bring it back. I'd have to go find video to make sure I'm right about that. But I'm pretty sure I am. But yeah, the big giant trash can arm, that was one of the Anthony Lapp designs that never got put anywhere because they realized they could just always knock over trash cans and intake them just like they were doing totes, and they would be fine.
The giant grabber arm made it onto JVN's top 10 most ridiculous designs list.
That sounds about right. It was crazy because you see like the joint at the end, like we'd have to go back and look at the video, but it grabs it one way, it grabs like sideways, and it flips it over to make it vertical, and like there's a joint that pivots while it's like moving up. It's impressive. It's a really cool design, but I understand why they got rid of it. This whole plate thing back here gets pushed so they can stack the yellow totes. This is kind of their ejector thing, so they can like push the yellow totes onto the step for the co-op bonus points. They had a few different things up here that I don't remember how much of these actually, I don't know which of these actually existed, but there were different things like hold the trash can at the top and not let it fall off if it was vertical. I'm not sure what ended up staying on the robot or not. This thing is what's known as a string pot. So this is like basically, it's a sensor that measures rotation inside of it, but as you pull the string, it can tell you how far you've pulled the string. So it's kind of like a one of the retractable lanyard things, except it can tell you how far away it goes. So it's like a tape measure, but it can tell you just a straight distance. So it's nice for things like elevators or things that can tell you exactly where they go. They're also very expensive. And most of the time we don't need to be that precise. So we just use the encoder somewhere built into a motor or something. Now with brushless, we could easily do that just like we have with all of our elevators or anything else and be fine. But yeah, string pots in general, like there's some DIY versions you can make that are cheap, but then you still have to fiddle with them a lot. The good industrial ones are $100-something bucks easily, if not more. Other questions about the robot?
In the top right, what's the weird 90-degree thing?
The top right, this thing?
That thing.
This was one of the things that like would hold in trash cans or stacks. I think it actually held in this trash can. So it would like, this could close and it would like come across better. I think it would hold in the front of a laid down trash can. So if the lid was like over here, this would come in front of it so it couldn't fall off forward. Other things this year. So one of the more annoying parts about this season was when they initially released the rule, they gave you a starting height, which was 6'6". I know this because it's exactly my height in shoes, which is a whole host of reasons very difficult for most inspectors to inspect because I can't even be eye level at 6'6" without standing on something because my eyes aren't at the top of my head. So people who are shorter than me, it becomes even harder because you always have parallax error because you're always like looking up at the thing, so you can't actually tell if something is the right height. That came into lots of importance, especially Dallas 2015. Story for another day, but there were DQs because people were over height. It was bad. But so you could start 6'6", but according to the manual, your crates couldn't be more than some certain height. I want to say it was 6 feet tall, the ones you had to ship to champs. So a lot of teams tried to figure out, okay, how do we build parts into our robot that we can like make it shorter when it travels? So like this plate here, I'm pretty sure, yeah, so these are two different tubes that are like attached together right here in the middle. So they could make it shorter going if they had to put it in the crate. We did the same thing. We had like top pieces that we would take off and then bag so the robot wasn't that tall. Because one, you would like have to also like getting a 6'5" robot through doors and like into the bus and like all sorts of things. Like when it's on the cart, you just can't do, right? You can imagine literally just like trying to move me standing up like on top of the cart. We're not fitting through a lot of things. That being said, the Cheesy Poofs definitely just sent a 7-foot crate, and we're just like, what are they going to do? And it was fine. Because the bill of lading said a different thing, too, than what the rule said. It's a whole complicated thing. I'm pretty sure there's lots of Chief posts about it if anyone cares about an incredibly non-important detail of First history. Okay. Any other questions about their robot?
What's that neon yellow thing on their like it's like right above there. It's on that like pink hook thing for the trash cans.
What give me some.
So okay, so the trash hand hook, the pink one on that bar, yeah. What's the green thing for? Yeah.
Oh, so that's how that's how they mate the different tube, right? So what are we looking at? So this is how do they build that? It does seem odd. Okay, so lower, let's see what it says. Maybe. Oops, SolidWorks being slow. Wait, how does that even work?
That's what I'm confused about.
So one of these is one piece. I don't know how this piece is mounted. This piece just seems to be floating. I'm assuming this is very different. Like,
Just a
yeah, there's no
scoop
hole.
for the inside of him.
Yeah, I'm
I feel like this was just not complete in CAD because this
Okay.
is not buildable. Like it clearly isn't buildable. There's no hole to mount the tube. There's nothing there. It's like magic. Yeah, next time we're at Johnson Space Center, like we're in their shop, bug somebody to see if you can like find a step stool and look at it because it's sitting up on one of the totes, like the whole robot is. But I have no clue how that works. Because yeah, this pink thing's not held on to anything in CAD.
Mhm.
It's just magic. It might be welded. It's very possible they welded that.
Okay.
That actually would make sense. It's the diameters are right. Yeah, that actually is probably a welded tube right there.
Well, they do that.
Double-sided tape.
What? Yeah, so that's probably welded, and then that gives you these flanges, which is like on a bushing probably of some sort. Not sure why they're clamping the whole tube. I'm not sure if the whole tube rotates. I'm not entirely sure. But yeah, my guess is this is probably a weld.
Okay.
And then it's for some reason these mount to that flange. And this might just be like tacked onto here too. They could weld into there. Seems like a weird choice to not put any sort of flat thing on that plate. I don't know why they would like add a just decorative plate, but it would not put it past them to do that. Okay. Any other questions?
Where's like the cloth thing mount when it existed?
On this tube. I'm pretty sure they used the same tube or something very similar to this tube. They may have like lightened it once they needed less room, but I think it was something close to this.
What's the white pole sticking up?
I'm hoping this was printed and that they didn't machine this. They might have machined this. This is ridiculous if they machined this. This is a ridiculous part. I hope they didn't machine it. They might have. I'm not sure. What's the white what?
So if you zoom out, more out, what's the white pole sticking up with the red thing on top?
This is the can grabber.
Oh, okay.
This is to get it off the step. This was Rev 1. The final version was carbon fiber, like a lot of carbon fiber, and mounted down here. There's like a big H frame that went down and had things on different angles that it would grab both cans very, very quickly, unbelievably. Well, I'll pull up a match in a second. Any other questions in the CAD? So this part, I know for sure the whole truck assembly, this was printed. I know for sure that they printed this. I think it was out of Ultim, but we could do it out of honestly, there's no contact in this game or anything. You could easily have done it out of PLA and been fine too. So that is definitely something you could print where you want some kind of weird geometry and it's this weird part. Printing something like that instead of trying to build it piecemeal makes a lot of sense.
What are those red plates holding on either side of the blue of the 3D printed part?
That's a good question. I think their CAD is weird and like there are probably multiple versions or something, or it got weird when we imported it. I'm not sure exactly how that holds on. It's mounting a plate down here. So there's like a stiffener plate across it, and then this plate is probably mounting the back side of this green one in real life. It's probably what's happening. That would make sense that this is probably forward and mounting there because it's clearly not inside it, right?
Yeah.
Yeah, it almost certainly is because this plate is also doing that, right? This plate is here.
Okay,
and it's
yeah.
that. So this is almost certainly in real life that this whole green plate is farther forward and riveted on there.
Okay.
I know there at one point they added a bunch, like when you look at the actual video, there's like a white wheel and stuff, and there's some other things that they interchanged throughout the season when they were adjusting and iterating on all of the tote grabbing, intake, and everything. It's hard to see here. I need to find some other stuff to figure this out. This also doesn't exist. Like that's not a thing. It's not double versus planetary. I don't think. I'm pretty sure it's not. I can't imagine. I would have noticed that. So this is actually really, really cool. It's going to be hard to explain, so I need to find better pictures at some point. But basically, this motor that is here is like a normal motor. normally it just drives the wheel, right? That makes sense. This motor drives the wheel. So then you're like, wait, what is this chain back here doing on this pulley thing, right? And there's like this weird arm thing. What is all of this? Okay, so real fast, this little tiny thing right here, right? You can kind of see the cylinder that's going through this yellow thing. This is like one of the tiniest pneumatic cylinders you can buy. So an air hose goes into the back of here, and it pushes out the front of this little thing by like half an inch. Right? This little green thing moves like forward towards this purple thing like half an inch and comes back with a spring when you release air. Right? Okay, so this is moving. So this whole reddish purple thing also moves because it's mounted to the green thing, right? And it's pivoting right here. So when you push this forward, it disengages this like cut gear teeth thing from this gear. That makes sense? Like this is gonna pull away. And so now this gear can spin. And what that let it do was when this released, oh, no, sorry. When this was, CAD's missing some stuff, so I might get this wrong. It's one way or the other. So if I say it backwards, I'll apologize and figure that out later. But either way, at some point, either when this gear is engaged or when it's released, when the motor spins the wheel, it also spins the pulley, which lets this whole arm move out or in. So they're using the same motor assembly to actually like swing open their whole intake. So if they want to like let a trash can in, they can open the whole thing out really wide, drive a trash can in, and then close it all around it. They can also like they can change how things are moving using just this motor and the pneumatic. So instead of trying to like figure out how to have a weird cylinder out in space they weren't allowed to mount to, because you can't just like put a pivot out here, right? It'd be really hard to figure out how to rotate this thing, or without having another motor to spin them in and out. They figured out how they could do it with incredibly tiny little McMaster cylinders.
So is that why it's so flexible when it can like pick up the actual totes and it just like goes so easily?
Yeah, they can
like
leave it where it's like
around?
not even. They can leave it where it's not powered at all and kind of like flap around and stuff. They can change.
Okay.
They can change some things about it. And yeah, they can move in and out, and then they can lock it out wider, however they need it to. There's definitely some missing bits because right now it's basically not mounted, right? Like this is the only thing touching this rail to here, and it clearly doesn't mount it. So I'm not sure what's missing in CAD, but somewhere in there, I'm pretty sure there's like plates in this gap right here between these two red parts. I think there's a plate that mounts here and here. Yeah, some version of that. But yeah, that was a really cool. And there's some, I can find the links and I'll post them in the Slack where like they have the chief posts that show exactly how that works a little bit more. Because I know it exists somewhere. Because I'm pretty sure there's a chief post. I've also got the explanation in person, but I'm pretty sure it's documented somewhere. Okay.
Those wheel hubs are pretty cool. On the intake.
Oh yeah, they custom made their own wheels. They did custom make their own wheels.
Can we ask them for some so we can use them on future robots?
I mean, we wouldn't be allowed to use them on future robots. I don't think that works with 30 minutes and hand tools. I don't think you can stretch the 30-minute hand tool rule to custom-made 118 wheels. Oh, okay. Any other questions? The stuff up here is largely just sheet metal. It's just like flat plate with sheet metal C's that they mount in there and rivet across, which works pretty well. Okay. I'm going to pull up one of the final matches from when they won Einstein. Ooh, why is my caps lock on? That's not good.
Are you doing one or two? Because one they grab one can. In Einstein 2, they lose the can grab.
It's a good question. Choose a better story because of the whole fact that the robot was destroying itself. So we're gonna do 2. Or do people? I mean, in theory, it takes all of 5 minutes to watch them both, so we can just watch them both. How about that?
Yeah, let's just watch both.
We can watch 2 and then
we're gonna watch Finals 1 and then we're gonna watch Finals 2.
The can grab is the only interaction.
It's their only what?
Can grab is the only like interaction with the other side.
Oh, that is true. But you still want to see what happens. So yeah. So again, the way this entire game came down, the very first sub-second. Like I don't know how I can like explain to you how ridiculous this was and why FRC should never have races in it ever again. We learned this in 11 and 15. The amount of engineering that went into figuring out how to get sub-second can grabs where teams were literally taking high-speed video and counting how many frames it took them to go from start to having the cans on their side of the field, like how to go to start to in can and then how to pull away. Like so much research. We were there at 118 for a little bit of it, right at like as they were doing it, prepping for champs. We were there the week 7 Saturday, like we normally are for Michigan state champs. And yeah, they were doing all the dev work, and it was just insanity the amount of work they put in, and all the teams put in to be able to do this. Citrus on the other side have these giant like axe-like looking things that grab the cans that are horrifying. I understand why they built them that way, but I would not want to be hit by those at all. Okay, so we're gonna watch this. Understand it's very fast. I may pull it back and actually watch it in slow motion in a second. Doesn't They don't even score this stack because they know they just don't need it, right? That's not worth the risk to try to place it and maybe knock down other stacks because they were clearly ahead. So that entire match was basically won outside of like being able to execute, but there's no strategy change you can do outside of that first incredibly fast amount of time. So we are like, no, he's still on the field. He's still on the field. So slow. That's how fast it is.
Wow.
It is. Right, and then so that was actually one of the bigger problems, and one of the things that Citrus Design did really well was if you notice those bounce. Yeah, so the reason 118 loses that can is it bounces when they hit it. It hits so hard that their hook bounces up. So like Citrus's like weird axe things drive the cans towards them when they hit, and like kind of force them to hook so they can't bounce. But yeah, like all of that design is so complicated. There's like this like curve that has to be done here to get the stick over the whole launching point and everything. There's so much geometry and a lot of surgical tubing involved in releasing these things that fast. Okay. Einstein Finals 2. Not at 0.
Drivers behind the line. 3, 2, 1.
Yes, they get stuck on the cam with 987. $118 knows that they do that. They try to release the can because they'd rather not be stuck there. Very, very close. Yeah, no good. Like 118's robot, it backs away and he literally like throws himself into the step where it's not precise at all because he knows he has to like hold it there. So it's actually a really scary moment in which their drive coach, Mason, grabs their driver before the timer ends And Crispy is very scared because he's like, oh no, I can't let go of this joystick or the robot's going to shoot forward and run into both of these stacks. Luckily, it does not happen, and they did win the world title, so that was exciting. But yeah, that's the game. When it's played like this, it's actually pretty cool because everyone is stacking everything, and it's awesome. When it's played at most matches during the season, none of these things happen, and there were like a few totes thrown about the platform, and like sometimes there were a few stacks. But yeah, so this was when 118 won the world title with Citrus and Birdbrains, and since this point, they have been in the same division with Citrus and 118 multiple times since then. It happens a lot. 2017, they were world finalists together, and then 2018, they were in the same division.
2019, Carver.
2019, they were in the same division. Yeah, they get in the same division a lot, which you would think wouldn't happen very much when they have now 6 choices, but it happens a lot.
There's probably other like 2 teams that have the same thing together. You just don't recognize it because they're not.
Oh yeah, almost certainly. It's just interesting that theirs is like so often, right? We listed 4 for sure in the last 5. Yeah. Right. The only one we're not sure about is 16. I think they were indifferent. I think they were indifferent in 16, but I'm not sure.
I think they were too.
Okay. Cool.